Hello all, welcome to CodeUp. Today let us solve the lead code's daily challenge and the problem is minimum window substring. And what does the problem states? Given two strings s and t of lengths m and n respectively, the minimum window substring of s such that every character in t is included in the window. If there is no such substring, return the empty string. That is, given two strings s and t of length m and n. S is of length m and t is of length n. Let us say this as source and this as target. Source, this as target. Return the minimum window substring of s such that every character in t is included in the window. Every character in t, every character in the target should be included in that particular window, and we have to minimize that particular window. That is what the question states. If there is no substring, such substring, if we cannot form a substring which is containing all the characters of target, then if it does not contain, we have to return an empty string. That is what the problem states. So let us quickly go into the example cases so that it will be clear what the problem states. So the string s is this and the string t is this. As you can see that the string t is having a, b, c, and the test cases will be generated such that the answer is unique. A substring is a contiguous sequence of characters with the string. Okay, fine. And yeah, the constraints is m and n can be varying from 1 to 10 power 5, and s and t will be having both uppercase and lowercase characters. So we have to take care of that also. It is containing both uppercase and lowercase characters. Okay, fine. Now let us try to, could you find an algorithm that runs in order of m plus n time? So let us see the examples. So this is the string s and this is the string t that is given, and we have to see whether the substring is containing abc. That is the problem. Basically, that is the problem that states here. So let us take this string ado. Does it contain abc? Does not have. The string ADOB, yes, it contains the string AB, but it does not contain contain the character C. So obviously it is not going to be true here as well. And let us try take this case. As you can see that ADOBEC, this is a substring where this substring contains the characters A, B, and C that many number of times that target is containing. So this substring is of length 6, and this could be a possible answer, but we have to minimize our answer. That is what they are expecting. So this substring is of length 6, and this is this substring is nothing but ADOBEC. Okay, fine. But can we come up with some other optimal answer with the smaller length? Yes, there exists one answer which is BANC. This is a substring where you can see the string contains A, B, and C, which is where that it can where it is equal to T as well. So this is a good. This is the possible answer, and this is the most optimal answer for this test case. That the answer is BANC. As you can see that A appears once, B appears once, and C appears once, and it is of length 4, and this is the minimal possible answer, and they have returned the minimum length substring, minimum window substring that contains all the characters that is occurring in T. Okay, the minimum window substring BANC includes A, B, and C from string T. Superb. So let us try to look at the example 2. In example 2, as you can see, S and T is A and A. Let us come here. As you can see, in the S string is A, S string is A, and T string is as also A. And you can see there is only one length substring which is containing A. So obviously the entire string, the minimum length is obviously 1. And this is the substring. Super. Now let us try to see the example 3. The S contains A. S contains A. and T contains the string A. Both that's they have why they have written empty string. As you can see, there is an A, but here also there is containing an A, but it does not mean that even the frequency of characters that occur in T also matters here. So the frequency of characters is 2 for the lowercase a, and there is only one a here, so you have to return an empty string obviously, because the length of the target string is obviously greater than this source string. So we can return an empty string here. This will be a base condition here, because if the as you can see, the length of t is greater than length of s, so obviously we cannot find a windows window at all, which is which is going to contain the string t. So what we can say is, first we can write a base case and then we can go to the approach. M is nothing but s dot size and n is nothing but t dot size. If my size of target is greater than m, which is source, then we can return an empty string. So this is obviously going to be a base condition. Okay, fine. Is it is case sensitive? Yes, it is case sensitive. This will be a possible counter question that you can ask to an interviewer: is it case sensitive or not? If it is containing a here, is it valid or not? Let us try to give the test case and check whether this is valid or not. As it is not given in the problem clearly, we can try to check by giving this. The S string is A and A, and T string is AA. If it is case insensitive, then it should return AA or else empty string. It is case sensitive, since it is returning an empty string, it is case sensitive. Okay, fine. Now let us try to solve this problem. How we can solve this problem? I can use a window, since it is a minimum window substring. Obviously we can think of something of a sliding window problem, where you can have a window size where you can expand your window until you have the characters that also appears in t string, and you can contract the window when there is a break in condition, or we can contract the window when you have an excess of characters. How am I saying that? Let us try to see here. As you can see, there is 1a, there is the frequency of a is 1, the frequency of b is 1, and the frequency of c is 1, and this is the characters we want. So let us try to expand our window. This is our string, right? This is our string, and I will try to expand our window. Does it satisfies the condition? It does not satisfies. So then we can add d. Does it satisfies the condition? How I'm saying it satisfies the condition? Whenever I'm adding, I'm going to have a map, and I'm going to store the frequency as well. A is 1, d is 1. Then we will be adding o. Is it satisfying the condition? Satisfying the condition means it should satisfy all the characters that is present in d as well. So it does not satisfy the condition. We can put the frequency of O as 1, and we can expand our window. B is also not satisfying. Then E, we can add it to our map. Then C. When I add C, where we will be about to add it to our map also. As you can see that this map satisfies the condition, this map as well. This is the map of the target string. It stores the frequency of that target string. So the frequency is greater than or equal to this ABC as well. So we can try to contract that. Because we need a minimum length substring, right? We have to have a minimum window substring. So how I am going to do that? Yeah, obviously in sliding window technique, we will be having a start pointer and an end pointer. Whenever there is a condition that becomes true, we can try to contract our window such that this condition still holds true. If it is not holding true, then we don't want to contract our window. If I erase this a, obviously this frequency of a becomes 0, and this condition is not valid at all. This condition is not valid at all. This condition, in the sense, a is frequency is 0, b 1 and c 1, but here the a is 1, b is 1, c is 1. So we cannot contract our window. So we can leave this. We cannot contract at this particular point. So we can try to expand our window again. So we will try to add O. The frequency of O becomes 2. Then we will try to add D. The frequency of D becomes 2. Then we will try to add E. Then the frequency of E becomes 2. Then we will try to add B. Then the frequency of B becomes 2. Each and every time I am doing, I will see whether I can contract the window also. Until this point, we cannot contract the window because I have only one A, 2B, but one C. As you can see, the starting point is itself a A, so obviously I cannot move the starting point and contract the window. So that is what the point I am stating here. That is what the point I am making it clear. Why am I not contracting the window? Since the starting point itself A, and we have only one character A, so obviously we cannot do it. We cannot contract this window by eliminating that A. That is what I am saying. So next we will try to add A, and whenever I add A, the frequency of A becomes 2, and you can see that at this particular point I can contract my window. How? Because if I move this, if I move this, yes, that is, if I eliminate this one character A, this the frequency of A becomes 1, and still it holds true. As you can see that A is having one character of A is present, and at least one character of B is present, and at least one character of C is also present. So this condition is holding true, and obviously I can eliminate this particular A. And I want to check whether still it can be contracted or not. If I can contract this, then I can form a minimum Windows substring, right? That is what I am doing. This start and end is going to update or going to keep track of the minimum Windows substring until this particular point. So obviously I can eliminate this D because D is no longer needed here, because it does not contain, the target string does not contain. So start will be moving one step ahead, and O also can be eliminated. Again the start moves one step ahead, and the B can be eliminated or not. Since the B, why the B can be eliminated? Because there is some another B that is present beyond this particular index. Yes. So obviously there is another one. There is only another one B which is greater. This B is greater. The frequency of B is greater than or equal to the frequency which is needed. So obviously I can eliminate this one particular B and move my start point. Now he is an unnecessary character, so I can eliminate this particular character and move further. C is also C is not an unnecessary character. As you can see, in my target string I need one character of C, and in my source string I have only one character of string. If I eliminate this particular character, then obviously if I move this point, and if I reduce this frequency of C, then it become then this does not satisfy the condition, and obviously I will be not having I will not be holding that particular condition. So I cannot remove the start point. Now we have a start and end point, and this is the particular string at this particular point, which is minimum, which is CODEBA, which is containing A, B and C, which is needed in the target string. Now we can try to expand our window again. Now we will move the end pointer, and we will store the frequency of n, and now also we cannot try to contract this window. And now at this particular point, when I add this particular character C, the frequency of character becomes 2, and as you can see that the frequency of source character is greater than or equal to this start character, so obviously I can move it. Obviously I can move that particular character. That is what I'm stating here. So I can contact this window. Yes. the frequency of C becomes 1, then O is an unnecessary character, I can remove that, the frequency becomes 0, and D is also an unnecessary character, I can have a frequency 0, and I can move the start pointer, and E is also an unnecessary character, we can move the start pointer and we can decrement our frequency. And now the start is at B, and at this particular point I cannot move the start character, as I said before, as I previously said, we cannot eliminate this B because I need at least one character of B here. So that is what my approach is. I will have, so finally the start and end is at B, A, N, C, and this is the minimum window substring till now. That is that I can get. So what I will do is I will traverse the whole string, and I will have a start pointer and an end pointer, and I will make the end pointer to move, and each and every case when I satisfy the condition I will try to contract the window as well. Whenever I contract the window I will also keep track of the minimum length substring. I will keep track of minimum length substring, as well as I will also keep the start index, because at finally I can return the substr. If I cannot form the minimum length at all, then I will return an empty string, or else if I got some minimum length substring, then what I will do is I will return s dot substr of the start index. At that start index I will take this number of length and I will return. This will be my resultant string, obviously. So hope you understand this approach, and I have also made a dry run here for this particular example one. So we can try to code soon and see whether we can complete it soon. Okay, fine. Now let us try to code the approach. What I need, I should have a map first for storing the frequency of t string. For that, what I'm going to do is I will have a map, unordered map of characters, unordered map of characters, char, comma int, mp. Or else I will say this is going to store the frequency of target, frequency t, and also I will also have a frequency yes. This is going to store the frequency of yes string. So for each and every character, first I should take the frequencies. So for each character ch in t, I will store the frequency t of ch plus plus. So now I have the frequency of that particular character. Now what I have to do is, now I should traverse the yes string. So for that I should have a start index, which is going to be at 0 initially, and finally at the end of the day what I'm going to do is I'm going to return s dot substr of start index comma min length. So this will be my minimum window substring, and I will also have a min length which is going to keep track in so initially this min length can be int max. Superb. If my finally if my min length is equal to int max, that is I cannot find any minimum length substring that is containing all the characters in t, so I will return an empty string. So this will be a base condition when I'm traversing the s string. If I couldn't find any minimum window substring, then I will return an empty string. So now I will travel. I should also have a start pointer which is at 0 initially, and an end pointer which is at 0 initially, and I will have a while loop while end is less than the size of the s string. The size of the s string is nothing but m. Until the size of the string m, I'm going to do a while loop. So each and every iteration I'm going to have a end plus plus. So inside this, what I'm going to do is, first I'm going to check. First of all, I'm going to add this particular character into my map, which is nothing but frequency of yes of. I will take a character. character ch is nothing but current character. Current character is nothing but, yeah, s of ch, s of, sorry, s of end. Now I have taken the current character. Now whenever I take the current character, I'm going to add my frequency yes map. So I will add the current character's frequency now. So once I have the current character's frequency, what I will do is I will check whether this satisfies the condition. If this satisfies the condition, so what I'm going to do here is I'm going to contact the window as whenever I enter, I will show the frequency and I will contract the window. How I'm going to contract the window is while my start instead of doing like that, while my frequency of t string, or else if my current what I can say is, if my frequency t string dot count of the mp of mp not current the character which is at the start index, the character which is at the start index, s of start, if this particular character is not present, is equal to 0, then this particular character at this particular start index is not present in my map. If this is not present in my frequency t map, obviously I can erase that particular character. Or else, if that particular character is present in my frequency t string, if it is present, what I should do is frequency of if this particular if my character a, as you can see that a is containing in frequency t map, and there is a 2a that is contained in frequency s map. If my frequency f of s of start is having a greater frequency of frequency t string of s of start, if this is also true, then what I can do is I can increment my start plus plus. Before incrementing my start plus plus, I'm going to decrement in my frequency s map. It can be quite confusing, but try to follow me, or else try to keep it in slow and see, or else trace it in your note. It will be much better. Either my current character should be not present in frequency t map, or else if it is present, the character which is at start index should be greater than the frequency t map. If it is greater, then I can erase it from my frequency s map, and then I can increment my start plus plus. Once I have contracted this particular window, what I'm going to check is I'm going to have a check function. This is going to check whether it satisfies, or I will say it as is valid. If this particular function is giving me true, what does this particular function, I will do that later. If this function is valid, then I will update my minimum length and start index. How I'm going to update my minimum length and start index is end minus start plus 1. Consider my start is at this particular point and my end is at this particular point. 0, 1, 2, 3. 3 minus 0 plus 1, which is 4. The length of that particular substring I am taking by using this formula, end minus start plus 1. If this is lesser than my min length, if this is lesser than my min length, then I can update my min length to be end minus start plus 1. Whenever I update my min length, I'm going to keep track of my start index as well. Start index is nothing but my start pointer, with the start pointer where it lies. Hope this is clear. And what does this isValid function is going to do? I am going to pass the frequency t map and the frequency S map, and that's it. I'm nothing else I'm going to pass to this isValid function. So I'm declaring this isValid function here. This is a bool function. Bool is valid. This takes a parameter unordered map of frequency T and frequency S. Okay, fine. Frequency T and frequency S. So what I'm going to do is, here I'm going to traverse for the characters T characters. I'm going to traverse for the T characters. So I will also pass another character, pass another string T. So instead of passing the T, I can pass this itself. So I'm going to traverse all the alphabets, lowercase as well as uppercase. This is going to traverse the lowercase. Or else I can have only one. Traverse both lowercase and uppercase. In I equal to 0, I less than 26, I plus plus, character lower is nothing but I plus A, and character upper is nothing but I plus capital A, I plus capital A. So now I have the lower character and the upper character as well. If my frequency string of S of lower, if my frequency string of S of lower is having a lesser than the frequency map of T of lower, then I can return false. The similar condition for upper as well. And if this is true, then return true. So what does this function does is, frequency T map is there where I'm storing A1, B1, C1. Consider I have a frequency S map where I have A1, then a A1, then a B1, then a C1. If this is my map, consider this is my map, then this A of 1, there is frequency of 1 is lesser than frequency T of lower, it is not. And in the frequency S of upper is lesser than 1 is lesser than frequency T of upper, it is not. For similarly for B and similarly for C. But whenever I think I am not having the character C at all. So if I'm not having the character uppercase character C, the uppercase character frequency of S of upper, it gives me 0, and the frequency T of upper gives me 1, and here there is a condition, the failing condition, so I'm just returning false here. So if it is not satisfying that particular condition, I am returning false. So hope this is clear. The isValid function is clear. Superb. Let us try to run the code and see whether it is coming proper or not. Okay, before running the code, let us try to scan our code whether it will give work failure case. Here I am taking the frequency, I am having a start index, midline, start and end, and I am having a sliding window technique where I am having a end pointer moves till n. And okay, if I am accessing a S of start where the start is greater than the size, then it can be a failure case. So let us try to do like this. If my start is lesser than m only, I'm going to do this case. If my start is lesser than m and the frequency T of dot count of S of start is equal to 0, where or else this or else if the frequency is greater, then I will decrement the count, and then I will increment my pointer, and if this is a valid case, then I will update my answer and I will increment and go to the next iteration. And finally, if it is int max empty string, or else return the substring that is needed. So let us try to run our code. Superb, it gets accepted. Let us submit our code as well. Superb, it gets accepted, and it is quite interesting because after a 1 year I'm solving this problem. And hope you like the solution, and let me know in the comments if there are any suggestions. And let us discuss about our time complexity and space complexity as well. Before that, let us see the yeah, time. It is making 299 milliseconds, so it is not much countable. So okay, so this is our problem for today. So the time complexity for this particular solution may be here, either we are traversing the string t, so it may take for order of n, the order of n, and this may take an order of m. This is not a square solution, it is going to be a linear only because we are using a sliding window technique only. So it may vary, it may go till order of m. So the time complexity will be order of m plus order of n, and the space complexity we are using a map of size order of m plus n, order of n. So that's it for this problem, and let us see in tomorrow's LeetCode daily challenge. Until then, bye. Hope this is quite readable and you like the solution. Let me know in the comments.